Okay. All right, so we're doing transformations of trigonometrical functions and also other functions like quadratic functions and cubic functions. And this particular exercise is from the book Edexcel GCSE Mathematics A Linear Revision Workbook. And it's the Edexcel's own book that's helping students to get themselves ready for the exam. Right, okay, do I have Layla with me? Layla, are you there?
Yes, sir.
Okay, lovely, Layla. Right, can you please, I know there's got a little bit dots and stuff on there. Right, read question 1, please, for me. And I'll highlight it, start you off from over here.
The graph of y equals fx is shown on the grids below. On this grid, sketch the graph of y equals f of x plus 2.
Okay, so I'm just going to use a red pen and I'm going to go over the bit that the bit that's the transformation part. So Layla, can you explain what does the plus 2 mean if it's on the outside of the function, completely outside to the right hand side? What's the plus 2 doing to the function?
It means that you have to bring the whole function up by 2.
So what's the key word that you want us to do?
Translate.
A translation. So if we were doing translation, we're not moving anything along the x-axis, we're moving everything along the
Y-axis.
So the translation will be y translation vector 0, 2.
Yeah.
So 0 along the x and 2 along the y. Okay, are we happy with that, everybody? So what we need to do now, we need to grab points. So I'm going to put points on there for you, points of the graph. And you need to grab those points and move those points 2 places up. So now if you look at the grid, so you got 0, 1, 2. So when you're going to go up by plus 2, you're going to go up by 2 blocks, okay? So everything's going to go by 2. So 1, 2 is going to be here now. So let's start doing that, please, on your graphs. So 1, 2 here, 1, 2 here. This point, 1, 2 here. Now I'm going to rub off all the extra squiggly wiggly bits. So just to kind of avoid any confusion. Otherwise it looks, okay, I missed one out. So this point here, 1, 2 is there now. So let's rub out the squiggly wiggly bits. Okay, now we have this point here as well. And this point here as well. So it's going to go up by 2, that'll be there. This point will be 1, 2 will be there. So we should have enough information for us now to redraw the graph. So remember, folks, nice and smooth graphs. Try not to draw triangles and straight lines, even though it's very tempting. Give it a nice curve to the graph. Right, so there's my graph now of f of x plus 2. Everything moves up by 2. Okay. Now the next graph, Layla, is going to be a little bit more something for you to think about for question B. So I want you to look at B now and read that question for me, please. Everybody should have that question done by now, part A. Part B, please, Layla, go.
On this grid, sketch the graph y equals f of half x. You only draw half of the...
Okay, now, remember what we done last week now. So that last week's function was a cyclic function and you could squeeze it down into half the place. Now, this is not a cyclic function. This is like a quadratic function. It's a negative quadratic function, that's why it's upside down. Now, we're going to have to squeeze the graph that we got there into half of the space. Let's now look at part B. Now, when it says squeeze it, we have to look at what's actually happening. So when you put a half inside, sorry, now that was half on the outside. If you put, what happens when you put a half on inside here? Let's have a look. I think you were talking about 2x. When you have like f of 2x, and we had our sine graph like this, we managed to get 2 of them into the same space. Is that right?
Yeah.
Now, similarly, if you put a half in there, you won't be squeezing it. You will be what?
Expanding it.
You'll be expanding it. So we're not actually making it smaller. I know it says a half, but we're doing the opposite of half. We're expanding it. Now, certain points are not going to move anywhere. So let's put the points that don't move. So the 0 point stays where it is because half of 0 and 0 is the same thing. Now, let's have a look at where this point goes. Now, when you put 2 in there into your function, what's half of 2?
1.
So you're actually working out f of 1 when you put 2 inside. When you put 2 in the function, you work f of 1. So the 1 is here. That point shifts to there now. Now, let's put 4 in there. Like, for example, 4. If you put f of 4, what's half of 4?
2.
2. So you're actually working out 2 at the position of 4. So this one here goes to there. So we are actually stretching it out. So that point, so let's try to join some up now. Let me use a different color. So we're going like that. And I'm going to get rid of all the other squiggly bits. Okay, so now let me go over what I've just moved, what's just been transformed. I'll show you. So this bit of the graph in red has become blue now. The bit which hasn't moved, it was the 0 bit. That one didn't move anywhere because f of 0 and f of half of 0 is the same thing. So now that red part has stretched over twice the space. It was between 0 and 2. Now it's between 0 and 4. Now similarly, when we look at this part of the, I'm going to do the pink part here. This part here again, we're going to have to now stretch it to out this way. So whatever was, we're going to double its displacement. So if you look over here, this one was here, which is, let's have a look. It's like 1 and a bit. And then you're going to move this one here by another 1 and a bit, which means what we're doing is doubling it. So it goes to here roughly. So I'm going to get the blue again. I'm going to extend it. So the pink part of the line function is moving towards is becoming the blue part. So we're moving it out, we're stretching it. Now let me color code another part for you. This part of the original function, which is green over here. Now which way is that going to go? Is that going to go to the left or to the right, Layla?
To the right.
To the right. Now we have to look at how far it was, and then we have to make it twice as far. So now we're going to get a little bit lost because we're running out of graph space here as well. Let me get rid of the side stuff. Give me a second. Let me make things a little bit more neater. Right, okay, now let's go back and get the blue again. So right, let's see how far. Let's go to this point here. So this is going to be from there here, 1, 2 and a bit. And then we're going to have the same distance again, 1, 2 and a bit. So that point there is roughly going to go to around about here. So I'm going to draw it for you. There, that's it. And the rest of the graph, Layla, would literally be down here somewhere. Yeah, off the graph, but we don't need to worry about that part. So the answer here in this particular one, I'm going to highlight it on top of everything. That's the answer there now. And let me get rid of all those different colors and take it back to the original color because I don't want everybody getting confused. And I'll just do in one color. So this question here requires a bit of thinking. It's different than our sign ones. Sign ones, I would say, a little bit more easier to understand, but this one here takes a bit more kind of working out. So don't forget, our original function is red, and the modified function is the blue one. Okay, and that's worth 2 marks. That's an examination question. Okay, right, fantastic. Okay, thank you for that, Layla. Let's have Dr. Ismail, please. Okay, Ismail.
Okay. Yeah.
Read. Let's go. Next question, exam question.
The diagram shows part of the curve with equation y equals fx. The coordinates of the maximum point of this curve are 3, 4. Write down the coordinates of the maximum point of the curve with equation a y equals fx minus 5, b y equals f minus x, and c y equals 3fx.
Fantastic. Now that gives you an opportunity now to put into practice what you've been practicing on the sine and cos curves over the past homeworks. So now remember what I said to you before. Let's just quickly go through what this here is. When they give you y is equal to f of x, what are they talking about here? Why have they used f of x? Why have they told what the function is? Because?
It's because it's a quadratic.
Okay, now yes, that is a parabola. It's a quadratic. It's upside down. It's a negative quadratic. But why have they used the language y because of fx? What are they trying to be?
It's not a sign, so they can't write sine x or cos
Okay.
x.
The answer I was looking for, they use y equals f of x. F of x is like a very general term. Like I said to you before, when I give you an example, so if I said to you, I drive an automobile, the word automobile means like it's any car. If I said to you, I drive a Ford Fiesta 1.6 liter VTEC, then I'm being very specific. I'm giving you the actual car. So when they mention y equals f of x, they're talking generally, this is a function. Yeah, we know it's a quadratic function by its looks. So they are saving writing down stuff like this. So they're not writing down y is equal to minus 2x squared plus 3x minus 6 as an example of a quadratic. But in this case, because it is upside down, it would be negative. But I'm just saying that's I'm just giving you an example. Rather than write all of this, they write it nice and neatly like this. Okay. So that is their general way of talking to us in the exam paper. Okay, lovely. So that's just to sort out some basic stuff. Okay, lovely. Right. So they want us to tell them what happens at this point. Is that right?
Yeah.
Okay, let's look at the first graph. Now they got the -5. I'll do the -5 with my red pen, and so that's the modification. They put the modification inside the function as a -5. What does that do to the graph? What does it do?
It'll translate by the right 5 to the right.
It translates to the right by 5. Is that right?
Yeah.
So it will be 5, 0. Fantastic. So everybody, let's have a look. So we got our original coordinates. If I write the coordinates as 3, 4 in vector 4 in column format, and then I add the 5, 0, what will that give us then?
8, 4.
It'll give us
8, 4.
8, 4. Now remember, this is in column format. They want us to write down the coordinates, so we need to kind of a little bit translate it back. So it'll be 8, 4, and they want the answer in that format.
Yeah.
Okay. So when they ask you for coordinates, normally that's how we write them, 8, 4. Okay. So what about the next one now? So I'm going to put the modification part. The modification is that bit there. So what have they done to the part B question?
Do you have to reflect into the y-axis?
Absolutely. If the minus is inside, it means it's a reflection. Why is my pen gone so flat? Reflection in the y-axis. So here's the y-axis. So there's our point here. You go boom over here. So where will it end up?
3, 4.
It will be -3.
Oh yeah, minus. Sorry.
Yeah, because don't forget it's 3 over here.
Oh,
Over here. If I extend it, then opposite of +3 is -3 there. Okay.
Yeah.
Lovely. And I'll close the bracket over there. Done. That's the second one done. Okay, next one. What's happening here? So they're putting the 3 outside at the front.
So do you have to move the values by 3? Well, times the.
Now you're not moving the values by 3, you're stretching the graph by a factor of 3. Remember, these points will stay stationary, but this point here will go zooming up down here somewhere. Yeah. So what was the height originally?
4.
4. And we're gonna take it to a factor of 3. So what happens to the y value of 4 becomes
12.
And what happens to the x value of 3?
It stays the same.
Stays the same. Fantastic, lovely. That question is got an A question, grade A question. It's worth 3 marks, and mashallah, you've smashed it. Okay, thank you for that. Let's have Ikra, please. Okay. Okay, Ikra, read question 3 for me, please.
The graph of y equals fx is shown on the grid. On this grid, sketch the graph of y equals minus f of x.
Okay, so let's have a look. We have, so what's the modification to the original function?
Minus.
Minus on the outside now. The graph, the question that Ismail done for us earlier, where was the minus?
On the inside.
Minus on the inside means what?
Reflection on the y-axis.
So what does minus on the outside mean?
Is it a reflection in the x-axis?
Absolutely, it has to be, can't be the same. So if you have a minus on the outside, you get a bit of speaker vibration there. Or should we say some feedback? What do you call it when it goes back in the sound? Reflection in the x-axis is the minus on the outside now. So let's draw our mirror. Okay, let's make the mirror a little bit thinner. The mirror is a little bit too. So everything which is above the graph, where does that go, Ikra?
Below.
And everything below the graph, where does that go?
Above.
So you're flipping up to down, down to up. We're doing a flipping action. Okay, so let's do that now together, everybody. So I'm going to color code it and do step by step. So this bit of the graph, original graph going up here, I'm going to flip it underneath and I'm going to go here in blue. Okay, I'm going to do the next section in red again. So the next section of the graph is going underneath the mirror line in red. So if I flip it, it's going to go above and I'm going to do that part in blue. Try to get your points to kind of match up with the, so they are accurate, so the bits as much as possible. Okay, so I'm doing section by section. Now let's have a look at the next bit. Original color is red. So here's my original part of the graph, which is above the mirror line. Now remember that part, let me get rid of, oops, wrong bit. Let me get rid of this. That part from the top is going to go to the bottom. So let's get rid of that. Let's get a blue color out. Now I'm just tracking it. It's here. So it'll be here. That part will be fixed. I'm just going to turn my pad around and I'm going to try my best to, whoops, that's going a little bit astray. Okay. So let me see if I can get a rubber into. Whoa, that looks lovely. Now, okay, if I don't say so. Right, the next part of the graph is going down, original. So where will the down part go?
Up.
Up. Now, try to track it and say, look, this part's over here. So it'll be in the same part above at the top. So you're planning the graph. Just don't draw any old lines in any direction. Okay, that part will stay there in reflection. So it'll go whoosh like that. MashaAllah, that looks beautiful. So now, we can label it y is equal to minus f of x is the blue one. Yes, that's our new one. And let's go back to red. Y equals f of x is our original one. Done?
Yeah.
You happy with that?
Mm-hmm.
Okay, lovely. Now let's do part B for me, please now.
On this grid, sketch the graph of y equals f of x plus 2.
Okay, now remember in your last homework you were doing sine and causes. Now you have this cubic shaped function. So and they're using the general term f of x. They don't want to waste time writing a big massive function. It's x cubed minus 3x blah 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 squared, all that kind of stuff. They don't want to do that. So they kept it simple. Now, so let me put in red. Let me see if I got the right thickness pen. This is the modification. They put a +3 inside the function. So what does that do to the function?
You're moving it left by 3.
Okay, so it's a translation. Okay, so we're gonna go, the x is gonna be -3, the y bit's gonna be 0. So we need to grab points now. You need to draw points on there, grab them and take them across. So let me put some points on for you. Copy them on yours, please. So when you do this in exam, do it like this. Everything we need to move it. So if you look at your scale, your horizontal scale, each box represents 1. So if it says +3, we got to go back by -3 to the left-hand side. So we're going left 3. So let's grab and count 3s, please. And let me grab a different color. Let's get a dark green. The easiest one to do is this one here. So we're going 1, 2, 3. Okay, so that one goes over there. And then this next one is one behind it. So we just put that in quickly. And let me get rid of all the squiggly bits because that confuses everybody. It confuses me as well. And then we can cheat a bit and say, okay, well, that one will be there because it's going to be the same. Okay. Next, we have this point here. That's going to go back by 3. 1, 2, and 3. So that point will be here. Okay. Now, what else? This point here will be going back by 1, 2, 3. Okay, so we're gonna have that one there. Okay, and that one will be just over there. Oh, that's nice. Okay. Okay, so we have this point here. 1, 2, 3. It goes there. Okay, so when you're drawing your graphs, please try to be as accurate as you can. Don't just rough it out. Okay, and then we're gonna go down by a bit, and then that's going to be 3 points. That's going to be up there. 1, 2, 3. Let's have a look what's happening. 1. Oh, it's there. So I got to bring up quickly, and then that one's going to go from here. 1, 2, 3, and then we're going to bring it straight down. Okay, that's the best I can do so far. So when they say you sketch the graph, they want you to sketch the graph. So for example, if you look at it carefully, the displacement here is 3, the displacement here is 3, the displacement here is 3, the displacement here is 3 squares. Everything should be 3 squares. So it shouldn't be more or less. It needs to be nice and uniform. Okay, let's get rid of all this extra stuff. All right, here we go. Let's get rid of all the extra stuff. Okay, lovely. Right. Do you have any more part of that question there? No, that question is finished. Okay. So Ikra, stay with me and let's do the next question together though. Come on. Do the next question for me, please.
The graph of y equals cos x is drawn on the graph below. On the grid, sketch the graph of y equals cos of x plus 90.
Okay, lovely. So now, if you look at it, the plus 90 is on the inside. Okay. I'm just going to mute you for a moment. I don't know whether that feedback's coming from your speakers or whatever. I'm going to put yours on mute for the moment. Let's see if that kind of beeping stuff goes away. Now the plus 90, okay, sorry. I need you to be unmuted so you can tell me what to do. Sorry. Okay. Ikra, come back in, please. Okay, so what the plus 90 mean?
That we're moving the graph left by 90.
So plus 90, so we're going to do a translation, okay, of the graph, and we're going to go 90 to the left. So it'll be minus 90. What do you do the y values?
They
stay at the same place. So we don't move it up and down, we just move it to the left. Okay, so let's grab the points and let's move everything back by 90 degrees. Okay. All right, let's try that. Now remember 90 degrees, so here's 0 and here's 90, that's 180, 270, 360. So, okay, so we need to move the graph back by 90 degrees. 90 degrees is worth 2 squares. So that's one thing you have to establish in the exam. What is the 90 degrees on the graph? How many squares? Everything has to move back by 2 squares. So this point here has to go there. This point here has to go there. This point here has to go there back by 2. This point here has to go there by, so let me get rid of all the extra stuff now. Okay, let's get rid of all this stuff here as well. So this is our plan. That goes there. That goes here. That goes here. Okay, what else? This point goes there. And right. So let's try to join those points up, and I'm going to put another color on them now so they stand out a bit more, because I've got reds everywhere now and I'm going to get confused myself, and I'm going to end up on the moon eating cheese. Okay, so let's have that. All right, let's try to join the blue dots up. I'm turning my iPad around because that's what I'm teaching on. If you, whatever your paper that you got the work printed out on, feel free, turn it around to get your nice curve. Turn it around again. Oops, and I've switched my monitor off. Excuse me. Sorry about that. I don't know what that's. Okay, I was turning around so much, I've gone so crazy. I've got the keyboard to hit the screen and I switched the monitors off. Okay, hopefully that hasn't affected our video. Oops, spin it down. Spin it down. Okay, let's take it up. Okay, from there 270, we've got to assume it's going to go down to here because we're pulling that part of the graph this way as well. And we're going to go, okay. So the plus 90 graph is going to be that one. That's going to be going back up again, because as that one goes up, that one will go up. Okay, whoops. So there's our new graph. Okay, let's get crab back in. Okay, folks, hopefully we are happy that I think okay, that was our original. And we stopped there, that's okay. We can't actually extrapolate this one back down. Whoops, I got the wrong color. Okay, that goes to 360. And then we could carry on going down. Oops, that's looking a little bit raggedy over there. Okay, that will come down towards that one. Okay, right. Next question, part B. Okay, on this grid, stretch the graph of y equals 2 cos x. Yeah, I think it's possibly your mic or whatever is bringing in. Okay, now to put the modification where, Ikra?
Outside.
Outside on the left hand side. So that outside on the left hand side, what effect does that have on the original function?
Is changing the y value.
So what are we doing to it?
We are stretching it.
We are stretching the graph. We're not translating the graph. We are stretching the graph. We are multiplying all the y values by 2. All of the y values. So if I put a dot here, and if you look at the y values of that dot, we're going to transform those dots, those y values. That's what we're representing now. Okay, tell me something special about these points here. What happens to the 0 y values?
They don't move.
They don't move. Because 0 times by 2 is still 0. So that part doesn't get stretched. It stays where it is. Now, let's look at this one now. So let me look at, what about this point here in green? What happens to the height of 1? What happens to it?
It's gonna be 2.
It's going to become a 2. Excellent. All right, let me get the highlighter again. What about this height here of -1 where the 180 is?
It's gonna become -2.
It's going to be multiplied by 2. -1 times by 2 is -2. Lovely. Right. What about this green point here at 360 has a height of +1. 1 times by 2 is?
2.
Lovely. Okay. So similarly, this green point here, it has a y value of -1. -1 times by 2 is -2. The 0, 1 stays there. They don't move. Okay. This one here, which is +1, we double it, gives you +1 times by 2 is 2. Okay, now we need to start drawing these points up. Okay, right, let's have a look. Okay, let's have a look. Okay, so we have, remember the orange points are stationary points that haven't moved, they haven't been enlarged, because you can't enlarge a zero value. You can't make it bigger by multiplying. Okay, let's have a look. So that should be my green graph that we should be getting. And we can extend the graph back down because it's going to go down here. Go down there, done. So the graph is in green, the new one. Okay. Okay, lovely. Thank you for that. Okay, now we are on question number 2. Let's have, thank you for that, Ikra. Eliza, question number 2, please.
Graph A shows the graph of y equals sine x. Use this to help you write down the equation of graph B. Describe fully the sequence of the two transformations that map the graph of y equals sine x onto y equals 3 at sine x.
3 at 2 sine x. Okay. Is that Eliza? Okay, it's Eliza. Okay, Eliza. So what about the first bit? How did the graph A become graph B? What did they do to it? What did they do to graph A to make it into graph B?
They transformed it down.
Okay, they transformed that down. They also moved it as well. So let's have a look. Let's have a look at 2 elements. Now remember the what's that? Sine x here, sine x. So where is that? So that point is at 90, 91. Now if you look over here, 180, 90, it's moved back by 45 degrees backwards. So the point that had it was 90 is now at
45.
45. So it's moved back by 45 degrees. If something moves back by 45 degrees, what do we see in the function? So we're going to see y equals what? Sine
of 45.
So don't forget the plus 45, you think of it as going right, but it's actually going left. So if they've moved left, that means in the function there must have been a plus 45 in there. So that's the first part of the graph. So y equals sine of x plus 45, because the graph has moved back by 1 square, which is the worth of 45 degrees. Recording. Okay. Now, what else has happened to the graph, Eliza? The graph had a height of -1, and now it has a height of 0. The -1 height went down 0. So what do we do to the height of the graph?
We've dragged it down.
We brought it down by how much?
By -1.
Done. Fantastic. That's it. So that graph is sine of x plus 45 -1. We've had a 45 degrees of the graph moving to the left. Then we have the graph also moving down. So we put those 2 transformations together and you get this lovely answer, which I've written down for you based on what you've been telling me. Right, now, here's our original function. How does it become this function? So you have to explain this bit and this bit. So how would you start? Which one would you start explaining first? The 2 by the sign or the 3 on the outside? Which one would you explain first for part B?
The 2.
That's right. So what is the 2 telling us to do?
It's telling us to move.
Okay, now what do we do with the elastic band?
Stretch it.
Stretch it. So they're telling us to stretch our original function by a scale factor what?
Of 2.
Scale factor of 2 parallel to which axis?
The y-axis.
Y-axis. Well done. Parallel to the y-axis. So we're kind of stretching it this way, stretching it to the y-axis. Okay, lovely. And let me change color now. So what about this +3 bit here? What's that telling us to do?
It's telling us to add 3.
Excellent. It's telling us to add 3. It's telling us to grab the graph and move it which way? Right 3, left 3, up 3, or down 3. What's that 3 telling us to do? In which direction?
It's telling us to go down.
Now remember, it's a plus 3.
Oh, it's telling us to go up.
And it's go up. So it's translation along the y-axis by everything moving up by 3. So we're going to write it down as a translation vector of 0 along the x and 3 along the y. And that's done. Beautifully explained. And that's another exam question done. I can't see exact. I think that's worth 2 marks as well on the bottom. So that's worth 2 marks. That's worth 2 marks. That question alone is worth 4 marks, just by understanding and being able to read the graph properly. Okay, that's lovely. Well, I think we're going to stop this video here, and we're going to make a new video for the next part, just to break the video down, because otherwise I think the video will get too long. Okie dokie.